Hello, we're Group 1, comprised of Wilson Wu, Stanley Sue, Trevor Morgan, Victor Negron, Amanda Coe, Tiara Gallen, Justin Holzman, and Jonathan Carter. This presentation will start off with our business case, follow with our implementation design. Then each member will discuss their roles in implementation. Our group has to develop a network for a company that has 3 departments. Department A has 10 hosts, Department B 60 hosts, and Department C 200 hosts. The company has 1 file server, 1 database server, and 1 remote office with 5 hosts. Access to the servers is allowed for all the departments and the remote office. The network must also consist of at least 3 routers, 3 switches, and 1 host for each department.
Hi, my name is Victor Negron, and I help design our network and help set up Switch 1. Our implementation consists of 3 switches, 3 routers, 1 host for each department, 1 host for the database server, 1 host for the file server, and 1 host for the remote office. Our network is also subnetted to have enough address space for all required interfaces and utilizes VLANs. We decided to use OSPF for our routing protocol as it works better with large networks, and we designed the network with expandability in mind. In our network design, we decided to include all 3 departments on 1 switch. For this, we use VLANs to separate each department. Using VLANs separates the switch into multiple broadcast domains to help reduce congestion, encapsulate each department into its own network, and it helps us subnet the network into smaller, more meaningful addresses. We decided to assign Department A to VLAN 10, Department B as VLAN 20, and Department C as VLAN 30. We subnetted our network in a logical manner to organize the available IP addresses that we would use on our network, and to also ensure that we have enough addresses for all hosts. We decided to use larger numbers for each subnet as larger numbers are easier to remember and distinguish. Department A was given the .10 subnet, Department B was given the .20 subnet, Department C was given the .30 subnet. Both servers use the .50 subnet. The remote host uses the .99 subnet. We also needed to subnet the serial interfaces between the routers. The interface between router 1 and router 2 used the .0 subnet, and the interface between router 3 and router 2 used the .1 subnet. We allocated each subnet to have over 200 available addresses and keep space between each subnet that gives the company an option to expand within its department. For example, Department A can expand to .11 subnet if needed.
Hi, this is Amanda Coe. My role was to configure my station in Router 3. I first started by installing the Ethernet cable and serial cables at Station 2. I then went over to the patch panel and from there connected an Ethernet cable from the serial cable port to Router 3 console port. After wiring my station, I set up my IP addresses, as you can see on the right, with the IP address, subnet mask, and gateway, and then configured my router. While I configured my router, Trevor Morgan came and helped me after he finished his part.
My name is Trevor Morgan, and I was in charge of setting up and managing Station 1. I installed Ethernet and serial cables at Station 1, connect the serial cable port to the Router 3 console port, and also assisted Amanda with the Router 3 configuration. These are the predefined addresses that were used for Station 1.
Hi, my name is Tiara, and my role in this project was to configure Switch 1. Switch 1 is one of the more critical parts of our implementation since this switch will handle 3 different departments, all on separate VLANs. We attempted to assign ports on the switch in a logical manner. The host of Department A was assigned to the first gigabit port, the host of Department B was assigned to the second, and the host of Department C to the third. The trunking port used was set to the last port available on the switch. In this case, it was the gigabit interface 24. After that, we connected to the switch via console to configure the switch. The next step was to create and name the 3 VLANs. Next, we gave access to the connected interfaces to their respective VLANs. Gigabit port 1 gets access to VLAN 10, Gigabit port 2 access to VLAN 20, and Gigabit port 3 gets access to VLAN 30. The last configuration needed on the switch is configuring the trunking port with .1Q encapsulation and setting the interface into trunking mode.
This is Stanley, and my role during the network implementation was to configure Workstation 5, which acted as our database server, and to also configure Router 1. The first step to this process was to make sure that the database server was connected to switch 2, port 2. The next step is to make sure that Router 1 was connected to Workstation 5 via a console port. After that, I turned off the router and turn it back on to enable a cold start. After heading back to Station 5, it is important to turn off the firewall. This can be done by pressing the start button and typing Windows Firewall into the search box. Look to the left panel and then use the Turn Windows Firewall on and off. Click on it and then make sure to turn off Windows Firewall for both and then press OK. The next step is to actually change the IP address of the database server. The IP address for the server will be 192.168.50.3. Subnet mask will be 255.255.255.0, and the default gateway will be 192.168.50.1. In order to manually change the addresses, first you would press the start button and then type network connection into the search box. This is the window that should appear. You should then choose the network with the connection, double click it, click properties, go to Internet Protocol version 4, double click it, and then use the following IP address. Click on use the following IP addresses and fill in the assigned IP address for the database server. The final result should look like this, and now database server has been set up. Next we move on to Router 1. You would have to click on the program PuTTY, click Serial, and then press Connect. A command window should appear, and now you have to wait for the router to cold start. After the cold start is complete, you would have to go to Privileged Exit mode, which can be done by typing enable or en. Next, it is necessary to go into global configuration mode, which can be done by typing in configuration terminal or conft for short. After getting into global configuration mode, you will need to go to interface gigabit Ethernet 00, and this is done by typing in int gi0/0, followed by the no shut command. The no shut command is short for no shutdown, which enables the interface. In other words, it brings up the interface. The next step is to set up the VLAN encapsulation. This command here, int gi0/0.10, is to specify the sub-interface on which the encapsulation will be used. The first 0 is the slot, the second 0 is the port, and then the 10 is the sub-interface. The line after that defines the encapsulation format and specifies the VLAN identifier, in this case 10. I would then repeat the process for each of the other VLAN, 20 and 30 respectively. The next step is to configure the router's IP address, which is done by right here, these two lines right here. After that, we implemented our routing protocol, OSPF. OSPF stands for Open Shortest Path First. We chose this routing protocol because Professor Hensel recommended it. these 4 lines right here. Defines the IP addresses on which OSPF runs, and define the area ID for that interface. And with that, router 1 is now configured.
Alright, hello there, this is Justin Holzman, and I'm going to be going over what I did for the group. I configured router 2 as well as file server A. Here's our packet tracer diagram. To get a better look, I configured this router, which is labeled router 1. I configured PC4, which was our remote server, which went through this switch, which had no configuration. Router 1, as you can see, Ethernet I configured to 192.168.50.1. I configured the 2 serial ports which connect to our other 2 routers as 192.168.0.2 and 192.168.1.1. And for PC4, I set up the IP address as 192.168.50.2, and after that we were able to ping successfully around the topography. Here is a picture of my setup at station 4. As you can see, there's a console cable that goes from PC4 to the back of the router, in which I used to configure, as well as the red cable which went from PC4 to the switch right here. So that's the console cable I had from PC4 to router 1, as well as a Ethernet which went from PC4 to switch to router. And that is what I did for the group.
So my name is Jonathan Carter. I was in the group 1, and my responsibility was station 3, where I had to follow these steps here. Install the Ethernet cable from the computer to the wall, Ethernet cable from the patch panel to switch 1, set the IP address to computer. Those are the IP address, the subnet mask, the gateway that I used, and assisting the other people once I was finished to make sure and to help them if they needed. This is the plug into the back of the Ethernet port of the computer, and then that red wire went to the patch panel into the wall, which in return went into the switch. Here is where showing proof that the firewall was off, and then that the IP address and the subnet mask was set, and then where I was able to ping later on once we finished the project.
Hello, my name is Wilson Wu, and I was the project manager for this team working on the project. I want to start off with managing the project. We had to find our needs initially. We had to figure out what the objective was and who, I guess, would be taking charge of that, and then creating the overall scope and plan of what we needed to do. And then we had to find the best approach, so we had multiple people actually designing the original plan, and then we chose the best design there was and the most logical one for us to be able to split amongst the team. Checking the design requirements, each one of the projects also had to, at least the designs had to meet certain things like having the right amount of switches, the routers, in addition to having the best or easiest way to program those switches and whatnot. We went with that, and so with this large team, initially we wanted to start off with 4 people, but then we ended up with having 8, and we got lost with all the people. Just everyone was doing their own thing, and the communication in the team was just slightly lacking. We got the whole team together, and just everyone started working together, and we were actually an organized team. Now, brings me to the point of managing the team, where once I came into control, I was managing the 7 people that are in the 7 other people that are in the group, and most of their questions were then centralized to me. And I think the largest part of me helping was just knowing the design and knowing what the individual members had to do for their project, and then just understand the largest point of failures, which would help us fix problems that we had or possibly had in the future.